Okay, so great, thank you. We'll get started. So first, thank you very much for joining the presentation today. Very much appreciate time this afternoon. And thank you to the LabWap backend team for inviting HyperAccel to present at their booth at SC25. So today's presentation is about HyperAccel and also about LabWap and how we're working together. But we'll start with HyperAccel first. We make generative AI fast, efficient, and affordable. So I think the first part, everybody knows, generative AI is exploding. But what may not be as well known is that access and availability to affordable and sustainable Gen AI infrastructure remains a challenge. And that challenge presents itself an opportunity. And HyperAccel steps forward into this opportunity with a unique Gen AI chip solution, specifically tailored for Gen AI inferencing, to win this challenge and to meet this challenge and to win this opportunity. So we make generative AI fast, efficient, and affordable. So HyperAccel is a Gen AI chip startup, hyper-focused on developing technologies and solutions specifically for Gen AI inferencing. Designed from foundational understanding of large language models based on transformer architecture, our LPU, LLM processing unit, aims for higher throughput performance with orders of magnitude gains in energy and cost efficiency as compared to the GPUs in the market today. So we dedicate ourselves to help our customers scale fast, efficient, and affordable Gen AI services for everyone. So if we wanted an elevator pitch, it's Gen AI chip. We are a Gen AI chip startup focused on generative AI inferencing, developing the LPU, our LLM processing unit, to deliver fast, efficient, and affordable Gen AI services for everyone. So our vision is that Gen AI is for everyone. And how we're going to do that is specialized LLM inference technologies for next generation processing. And the three main areas we focus on is specializing in LLM. That's what we do and that's all we do. And we only do the inferencing side, the servicing part, not the training part. It's a very focused and targeted application for our solution. And we're built by deep tech founders and building a world-class team from such companies as Samsung, Hewlett Packard, SK Hynix. And we have disruptive technologies with lighthouse customers. I won't go through the ones here, but our customers are Neighbor Cloud in Korea, which is equivalent to Google Cloud in the United States, and then also a global consumer electronics company for our Edge AI chip, to be announced soon. Briefly, our company history. We were founded in January 2023. We formed partnership with AMD, Neighbor, this consumer electronics company I mentioned. We've built our first product, the Orion LPU FPGA server. So our technology running on an FPGA server received seed funding as well as Series A funding, and made a tremendous progress in 2.5 years. And the leadership team is key to this, right? Our founder and CEO is a professor from KAIST University in Korea, which is equivalent to the MIT of the United States. He and his team of deep tech researchers were working on this problem before anybody had heard of ChatGPT. They had read the paper around the Attention is All You Need, the Google's landmark paper 2017. They were already working on this deep tech research within the industry. And then when ChatGPT exploded on the scene, they saw the opportunity to convert this technology that they had been developing in their research labs to become a commercial product. And then our CTO is from the industry side. So he's worked at Samsung, Nebula, so is a deep tech expert in NPU technology. So just getting into our product at a high level, we saw the need to specialize having deep knowledge of LLMs and the effects of large models, sequential processing, and memory intensiveness for Gen AI inferencing. So when you go through a ChatGPT query or any large language model query, you put in an input, hello, my name, and you get an output, is James Smith. But what's going on in the background is it's going through the transformer architecture of a summarization stage and a generation stage, where the input tokens, hello, my name is, processes through those stages and creates output tokens, is James, period, sequentially. So it's large models and sequentially processed. And then the next point that's really important for why the LPU is the right product for inferencing, the service side of generative AI, is that it's very memory intensive. So there's a memory bandwidth problem everybody in the industry knows about. GPUs do a good job when it's a compute-intensive workload, such as training. Pick the GPU for those kind of workloads. But when it comes to the service side, where there's small batches, memory-intensive, service and latency, we believe strongly that the LPU is the right technology for those types of solutions. And we built our LPU with unique hardware system designs to deliver on our promise of high performance and affordability. So how we get the high performance, whether it's in a single chip, it's a blue box, or the multi-chip, which is in the dotted box of cascading multiple LPUs together, we get our high performance through maximizing the memory bandwidth utilization. And we have a special technology called streamlined memory access and Dataflow architecture that allows that to happen. So in where most of our competitors are using HBM, so, sort of as a crutch to get the speed to solve the memory bandwidth issues, we use LPDDR5X, the same memory that's in your cell phone, because it's inexpensive, widely available, and low power. And through that, but we can get the maximum performance bandwidth utilization of that memory, so that we can get similar performance, if not better, than GPUs and other competitors out there for LLM inferencing. And then we also have specialized end-to-end compute engines to process the tokens, end-to-end, as well as adaptable hardware architecture for chip-level scaling and system-level scaling. For low cost, as I mentioned, we really stick to the standards, right? We stick to standard memory, standard LPDDR memory, as I mentioned, and standard connection technologies such as PCIe and Ethernet to keep our costs down, power budget low, and still get the performance because of our unique architecture. And this is the unique architecture. If you want to see the money slide, this is at a high level. It's what we developed, our proprietary and innovative technology around streamlined Dataflow architecture that allows us to maximize both memory and logic utilization, which is a key to getting high requests for T-flops, right? And so if you look in the top left, the traditional Dataflow that you see in most compute architectures today, and most of our competitors, is very limited data use. So they have a lot of compute units, and they're great for parallel processing. But when you're doing a sequential processing, token by token, there's a lot of going back and forth between compute and memory, which takes a lot of time, wastes bandwidth, wastes energy, and slows down the output performance. And how we do it is to help HyperAccel LPU Dataflow. We maximize the data reuse, right? So we transfer once, cores, and then process it one by one and get the speed out of that as well. So we don't go back and forth to memory, which is what's killing the inference, and we just transfer once and reuse many. And what the output of that is that while we have lower T-flops than GPU, as you can see, we have higher tokens per second, which is what you want in a service industry, right? You're looking for how many tokens you can get out per second. And then software. I mean, we talked about hardware, but hardware is you need software to work with hardware. And how we built the LPU stack again is very similar to the GPU stack, but also different, right? What we hear a lot of times is, hey, what are you going to do? I program everything on CUDA. And what we're seeing in the industry is, as the industry is moving towards inferencing, CUDA is becoming less and less important. Why? Because in the inference side of the workloads, most of the developers are going to the similar stack to what we built, right? Which is using VLLM, the open source framework, as well as Hugging Face Model Hub and PyTorch, right? That's what they're really using to develop their models. And we're fitting right in with where the future is going on the software development side of AI inferencing. So yeah, I'll end with my call to action is if you're working on generative AI and you're working on inferencing, then accelerate your LLM inferencing with the LPU products and join a growing customer partners. And we're here in booth 1316. We're happy to talk to you more in details about what we're doing. 3 main key products: the LPU chip that we're working on, the Gen AI server, which is commercially available based on FPGA technology, and then our LPU IP, which would be the Gen AI core within a customer's SoC. And we have many customers partnered, one of them being LabWell here and back end, so we're really happy to be working with them. And yeah, we'd love to work with you as well. And just a last slide I'll put in is a shout out to LabLab and HyperAccel's our partnership, right? And I put these as shout outs, literal shout outs, right? We're working on sovereign AI cloud together, right? Really exciting project around sovereign AI in Korea. We're all about software and hardware co-design, right? That's what we're hearing in the market more and more and more, right? It's not about, hey, I'm a model maker, you're a silicon vendor, you're a software provider, or hardware provider, right? It's about co-design to maximize the efficiency of each one's solution. And then why is that? Because we're all customer focused, right? We're all focused on the customer solution because the customer doesn't care what software you're running or what hardware you're providing. What they want is an outcome, right? A result. And that's what we focus on, right? And to give the fastest, most affordable, most efficient, most sustainable solution, we believe that working together, we can deliver that. And then accessible and affordable AI. I touched on that before, but that's what LabWAP and backend is about as well. You can just have your GPU and let it run, unmanaged, or you can have it managed by a software platform like LabWAP, and you can get the efficiency out of that. And you can get the same efficiency out of a hardware solution like ours. And then you can see the future promise of a software efficiency product like LabWAP and backend have, and a hardware efficiency and affordable product that HyperAccel is going to provide. And then we're all about open source and deep tech research. So a lot of connections between HyperAccel and LabWAP, and we're really happy to have this opportunity to present to you and then present in LabWAP's end booth. So thank you for your attention. And yeah, I'm happy to take any questions or